This example illustrates how phasors simplify our work with sinusoids by letting us get the solutions that we want without having to remember complex trigonometric identities or do some sophisticated manipulations. So let's just jump right in. It says that if y1 is equal to the sinusoid 2 times the cosine of omega t minus 30 degrees, and y2 is equal to 40 times the cosine of omega t plus 60 degrees, calculate y equals y1 plus y2 as a single sinusoid. And part A wants us to do it using trig methods. Okay. So let's go ahead and write it out and see what we're working with. We got y equals y1, so 20 times the cosine of omega t minus 30 degrees plus 40 times the cosine of omega t plus 60 degrees. Now the first thing we have to do is take advantage of this trig identity, which says that the cosine of a plus or minus b is equal to cosine of a times the cosine of b minus plus, so it flips the sign over, the sine of a times the sine of b. So let's first apply this to both functions here. So we'll get this rather long, kind of nasty looking trig expression. We'll say that y is equal to 20 times the cosine of omega t times the cosine of minus 30 degrees. That's minus, that's going to be plus, so plus 20 times the sine of omega t times the sine of minus 30 degrees, plus, now y sub 2, so that'll be 40 times the cosine of omega t times the cosine of 60 degrees. Now that was plus, so it's going to be minus, so minus 40 times the sine of omega t times the sine of 60 degrees. Notice that I distributed these coefficients into each expression. So we've got this big long monster of an expression. Now we basically just have to simplify it. So we'll say that y is equal to, let's first combine our cosine and sine terms. So we'll say that we've got 20 cosine omega t times the cosine of minus 30 degrees plus 40 times the cosine of omega t times the cosine of 60 degrees plus, let's put the sine components together, 20 times the sine of omega t times the sine of negative 30 degrees minus 40 times the sine of omega t times the sine of 60 degrees. Now in both of these expressions I can factor out the component that has omega t. So let's do this. Y is equal to, let's put in parentheses, 20 times the cosine of minus 30 degrees plus 40 times the cosine of 60 degrees times the cosine of omega t plus 20 times the sine of minus 30 degrees minus 40 times the sine of 60 degrees, and that's times the sine of omega t. All right, so we can do a little bit of calculation. We'll have y is equal to, if you punch those values into your calculator, what you'll get is 17.32 plus 20 times the cosine of omega t plus 10 minus 34.64 times the sine of omega t. And then when you go ahead and combine or do these arithmetics and combine everything up, we're going to get that y is equal to 37.32 times the cosine of omega t plus, minus 24.64 times the sine of omega t. Now, when we want to work with these guys, we want to combine them into a single function. So what's going to happen is we're going to put them into a triangle. And on the horizontally adjacent component here, we'll put 37.32, and over here we'll put 24.64. Since we're only interested in calculating the length of this hypotenuse, it doesn't really matter. So, let's see. Let's go ahead and make these calculations. So if we have the hypotenuse, let's go ahead and make the angle. Remember, hypotenuse is just Pythagorean theorem, Pythagoras' theorem, Pythagorean theorem, 37.32 squared plus 24.64 squared. That's going to give us a length of 44.72. And then that angle, we can just go ahead and do the inverse tangent of 24.64 over 37.32. That gets us 33.43 degrees. Now, how does that help us out? Well, we can do this. We can actually just multiply y by, remember we're going to multiply by 1, so let's multiply it by the value of this hypotenuse. 44.72 over 44.72 times the rest of this guy, 37.32 times the cosine of, not phi, I'm just getting used to writing that, omega t minus 24.64 times the sine of omega t. And then we want to only factor in the denominator here. So we'll write y is equal to 44.72 times 37.32 times the cosine of omega t over 44.72 minus 24.64 over 44.72 times the sine of omega t. Now, since this one is 37.32 over the hypotenuse, it's the same thing as the cosine. So we can rewrite this as y equals 44.72 times the cosine of that angle, 33.43 degrees. Degrees times the cosine of omega t minus, now same deal except it's the sine, of 33.43 degrees times the sine of omega t. Now, this is just that trigonometric identity that we used in reverse. So that's going to be y is equal to, we still have 44.72 times, so it's important bit is here that it's negative. That's going to be the cosine of omega t plus 33.43 degrees. And there we have it. There's our expression. I guess I can get rid of these guys right there. So that is our final answer, that y is equal to 44.72 times the cosine of omega t plus 33.43. And as you can see, this is a pretty sort of tricky thing to solve. There's lots of weird trig identities. Also, knowing to do this bit where you multiply by the hypotenuse over itself is sort of abstract. But we get the job done. We're able to solve this, get our single sinusoid using just trig methods. Now part B asks us to solve it using phasors. So let me jot that down. Part B. So we can jot down our phasors directly. So since we knew that y1 has an amplitude of 20 and a phase angle of minus 30 degrees, and y2 has an amplitude of 40 and a phase angle of positive 60 degrees, we can just say that y1 is equal to 20 at an angle of minus 30 degrees, and y2 is equal to 40 at an angle of 60 degrees. Now here's the catch. It would be really cool if we could just do this, right? 20 at an angle of minus 30 degrees plus 40 at an angle of minus 60 degrees. However, or just say like, all right, it's equal to, 20 plus 40 at an angle of minus 30 degrees plus 60 degrees. Now, if these coordinates are in the same line on the complex plane, this will actually work. But most of the time, that doesn't work. And we have to take our phasors from this form, which is polar form, and we need to convert them to rectangular form. So let's quickly make a note of that. Let's see, we're going to have, if we have our function y, it'll be the real component plus j times the imaginary component. And the way that works is the real component is equal to, let's see, the amplitude times the cosine of phi, and the imaginary component is equal to the amplitude times the sine of phi. So if we apply this to y1, so if y1 is equal to 20 at an angle of minus 30 degrees, then y1 is going to be equal to 20 cosine of minus 30 degrees plus j 20 sine of minus 30 degrees, just like that. And if we go ahead and punch those guys into our calculator, we'll get that y1 is 17.32 minus j10. And the same deal for y2. y2 is given to us as 40 at an angle of 60 degrees, which means in rectangular form it's going to be 40 cosine of 60 degrees plus j times 40 sine of 60 degrees. And that gets us y2, which is equal to 20 plus j 34.64. Now from there, we can just add them up directly. We can say that y is equal to 17.32 minus j 10 plus 20 plus j 34.64. Combine our like terms here, we'll get that y is equal to 17.32 plus 20 plus j minus 10 plus 34.64. That leaves us with a y equal to 37.32 plus j 24.64. And now basically we're solving the exact same thing as before. We want to convert this now back into polar form. So we'll say that y is equal to, or we want to get back our amplitude and phase stuff. So we need to convert it first back to polar form. That'll be the square root of 37.32 squared plus 24.64 squared at an angle of the inverse tangent of 24.64 over 37.32. And that gets us our y in polar form at 44.7 at an angle of 33.43 degrees. And now we can just put that back in our time domain form. Y is equal to 44.7 times the cosine omega t plus 33.43 degrees. And if we go back to part A, that's what we got. And we are good to go. So you can see with phasors, it's not like it's easy. Like, you still have to do some work, you still got to do some calculations, but you don't have to do any kind of weird stuff. There's no abstract manipulations, there's no trigonometric identities. It's all just pretty straightforward arithmetic. There's not a lot of crazy stuff that you have to do. So that is it for example 9.5.